Welcome, everyone. So we are going to be finishing up this missing link today. We're finally going to be learning how to convert standard form to vertex form and diving a little bit into the quadratic formula. So this was our do now for today. We're using the exact same equation to solve for x. And we're the first one we're going to solve by factoring, and the second one we're going to solve by completing the square, which you should know how to do both. So the one we did here first, remember this is both x and x. And this one right here is, remember two numbers that multiply to 8 and then add up to a -6. So we're like, well, it has to be 2 and 4, right? Because it can't be 8 and 1. Yeah, because the smallest numbers I could get is a 7, like 8 minus 1 is 7, right? So we got 2 and 4. And we know that both of them are going to be negatives because they both have to be negative in order to get a -6 like this right here, right? And well, let's see here. So, and we know that -2 times -4 is still going to be +8. All right. So then remember, we're going straight across. So it's x minus 2 times x minus 4. And again, we're using the zero product property here. So zero product property. And I don't know if you know, but in the back of your book is a glossary, right? So if you look up zero product property, it talks about that, or you could Google it, right? But basically what it says is that if you're going to multiply two numbers and we know that the answer is 0, that means either the left one or the right one has to be 0. Like one of the two has to be 0. So we want to find all the different possible answers. So we're going to set the left one equal to 0. So x minus 2 equal to 0. And then the right one equal to 0. So we get two possible answers. So we know that when x equal to 2 or 3, it doesn't matter which one, we know that it'll give me an answer of 0. And you could plug it back into here, into the original standard form, or you could plug it in here. It's a lot easier to see here just because they're already factored. So it's like 2 minus 2, that's 0. And it does not matter what this is. It could be -1,000,000, because 0 times -1,000,000 is 0. Of course, this is not -1,000,000. It's like 2 minus 4, which is -2. So it's 0 times -2, which is still 0. Okay, and you could do the same thing here. If you put a 4 in here, 4 minus 2 is 2. And then 4 minus 4, that's 0. So again, this is still 0. So see, we got both answers. And there are no other numbers that do that make this equal to 0. Okay, and then so these are our roots. So if we were to graph this, y equals x squared minus 6x plus 8, that's our roots. The x-intercepts are at 2 and 4. That's where it crosses. And we're going to solve it by completing the square. So again, it is equal to 0, so that's good. We are going to get just this binomial right here, the x squared minus 6x. So we're going to subtract out the 8. And then from here, we're going to set up the perfect square. Do you see in blue how we set it up? And the way we get this -3 right here is by having the 6x. If you notice up here, it's like if we have take that 6x and then we're going to, or the -6x, and we're going to cut it up into two equal parts, right? So it's -3x and -3x, which means that the side here is going to be -3. And so that's why we have this -3 here. And then we're going to square up, because in order to complete the square, that's called completing the square, we actually need that +9, because here we have the x squared minus 6x, which we have. And then in order to complete it, we need to add a 9 there to get that whole square. All right, so that's where it is. So we know that x squared minus 6x plus 9 is equal to, it's the same thing as saying x minus 3 squared. Remember, that's just the size. So it's x minus 3 times x minus 3. Okay. And then so now we added 9 to the left-hand side. So we have to add 9 to the right-hand side to keep that equal. So we added 9 right over here, and -8 plus 9 is just 1. And now I just recopied it down here because we didn't have a lot of room. And to get rid of the square, we're just solving for x. To get rid of the square root both sides. And whenever you square root both sides, you have to add in the plus or minus, right? So that's where my plus or minus came from. And notice that the square and the square root cancel out. So we have just x minus 3 equals, well, what happened to my square root? Well, what's the square root of 1? 1. So that's what happened to the square root. We simplified it more because it was simplifiable. And then we're almost x by itself, right? So we're going to add 3 to both sides. So x is equal to 3 plus or minus 1. And if you left it like this on the test, I mean, you're technically not wrong, but you're just not finished. Okay, you just need to simplify more because we can actually simplify this more. So we just had to go 3 plus 1, which is 4, and then 3 minus 1, which is 2, which is, as you can see here, the same roots. Again, here, this is not ordered pair, so please don't put parentheses around there. These are just what the x values are, so that's why order does not matter. Like, oh, it's 4, 2 here and 2, 4 here. Does that matter? No, it does not matter. Okay. So there we go. I do want to talk about this one. I know we didn't talk about it in class, but it's just literally changing it from, this is the vertex form using just ax squared plus bx plus c. So going from standard form to vertex form. But before we do that, we'll go on and I'll show you how to do it. Okay, and I feel like the way I'm doing it, it has a lot less steps, but we'll see using A, B's, and C's. So we're going to use this A right here, this, we never went back to graphing it. Oops, we'll do that. So again, normally remember we would add the 9 on both sides, but in this case, we have a Y here and we want to keep it with the Y, right? So what I'm going to do is I'm going to just put it out here. Push it aside. It's still on the right hand side. We're just pushing it aside because we're going to add a few things in there. Right now, using just these two guys, we're going to complete the square, right? So again, I set up my perfect square, the parentheses with the x and then square. And then we're going to be like, okay, remember this 8x? We're going to cut it into 2 parts, right? So this is literally going to be, this is going to be 4x here and 4x here, right? So that's why this is a 4, because that's what my sides are going to be. And then what do I need to complete that square? Is this part right here, the 16. So the 4 times 4, because all we would have left is the x squared plus 8x is just this part right here, right? That's not a whole like, let me use blue. So this part right here is just this part. This is all we have, is this part right here. Okay, so we need to add in this plus 16 so that to complete the square, right? And I'm going to use my purple again. So that's what we added the 16. Now, and as you can see, my yellow, these two are equivalent to each other. But remember, I just added 16 on one side. Normally what we would do is add 16 on the right-hand side. But I can't do that because I want to keep the y by itself. So what we do is, well, we're just going to, well, what if I add 16 and then take it away, right? So this is me taking it away. So it's, remember, we're still on the right side, right? So remember, I set this -9 aside, or this -9 aside, and we're just going to subtract 16, okay? And so I added 16 and subtracting 16. It's kind of like if your mom asks you change for 20, if you have like 420, like 4 $5 bills, right? And she has a $20 bill. So she gives you the $20 bill and you give her 4 $5 bills, right? So then she can have smaller change, right? So did she actually give you $20? I mean, yes and no, right? But do you have more money than you did before? No, right? So the same thing here. So we give them 16 and we take away the 16. So we're actually not, the value of this is actually not changing. We're just changing the way it looks. Kind of like how now you have a $20 bill instead of 4 $5 bills, right? It's the same kind of idea. And then so now this 16 is going to be found here, and this 16 is going to be found here. So that we're going to just combine these two guys together. So -9 minus 16, which is going to be -25 or -25. All right. So this is vertex form. I should just finish that out. Vertex form, which means that our vertex is -4, -25. Remember, this was opposite of what we see, right? It's normally supposed to be a minus. So the only way it became a positive was if we subtracted, or if 4 was a negative, okay? And we're gonna just plot that over on here. So let's just do some pretending. So here's -24, here's -24. This is my cheat way of doing it, right? I'm gonna put that point right there. And that's my vertex. And then my A is positive, right? So I know it's gonna go up. And looking at my, what is it called? At my this standard form, this is my y-intercept right here, right? So then my y-intercept's like, if that's -25, let's say about that is going to be -9, right? So I know if this is my vertex, my AOS is literally on that vertex. So, oh, I'm too far to the right. Let's try that one more time. Oh, that's pretty good. Okay, so this is my AOS. So I know that if I have a point here at -9, and this is like -4 away, or -4 away, it's 4 away, then over on here on the 4 away on the other side, since this is over here at -8, right? That's going to be my other point. They should be symmetrical. That doesn't look very symmetrical. Let me make that a little bit more symmetrical. About the same distance, maybe about there. So 4 away, and there we go. And then we're going to have our graph that looks like this. The only thing is that we don't have any roots yet, right? And so makes me want to think, can we find the roots? How do we find the roots? Oh yeah, completing the square, or maybe we can try factoring it. So let's try factoring it first and then going from, and then maybe completing the square. So because factoring is seems to be, or actually we're kind of close. We're not that far away. So let's just do it here. So instead of, because remember on the roots, that's where y is equal to 0, right? So, oh, well, I could actually figure it out here. So 0 is equal to x plus 4 squared minus 25, right? So we're going to use our power of logic. Well, how do we solve for this? I only have one x, so we're doing pretty okay. So I can actually just add 25 to both sides, right? Because I don't want to square root it just yet because I have this minus 25 out here. And then I would have 25 is equal to x plus 4 squared, right? And then from here, what I would do is, now I can square root it, right? Because it's just x squared by itself. And don't forget to add your plus or minus. And so this give me plus or minus, well, what's the square root of 25? 5. And that is equal to x plus 4, because the square and the square root cancel out. And then we're almost there, guys. We just need to get rid of this minus plus 4 by subtracting 4 on both sides. I'm just going to reverse it. So x is equal to -4 plus or minus 5. Now we can still simplify this. So it's going to, because I'm like, how do you graph that? Oh, and notice this -4 right here. Look, it's the same thing as that. Coincidence? No, I don't think so. Because remember, that is from the inside the parentheses, right? So this going to be -4. And then plus, so it's going to go 5 to the right, and then 5 to the left. Well, if I start at -4, how much is 5 to the right? Well, that's going to be 1. And sure enough, -4 plus 5, that's 1. And what's -4 minus 5? It's -9. So this is going to be here at 1. Oh, it's pretty close. There's 1. And yep, here at -9. That's my roots right there. See? Totally works. And honestly, if you wanted to try and factor it, we would have gotten the same thing of 1 and -9. And if you don't believe me, try it out. Try it. Well, you would factor using this original standard form. You can't do a factored form using this guy. Not vertex form. It doesn't work that way. All right. And I did say that I was going to show you with the we'll do this one next time. Okay, it's not completing the square this way is not really necessary because most people do it the quadratic formula way. I do want to show you guys how to do it how to deal with this madness. What is this madness? All right, and we'll kind of liken it to what we just did here. All right, so if you're like, Miss Lee, I can't, it's to give your brain a chance. If you really can't, then you can fast forward, but try not to. All right, so again, we have it looking very similar to that. So y is equal to ax squared plus bx plus c. So there is one thing we have to do. We, well, first let's take out the c. Remember, we gotta put that aside. So ax squared plus bx, and then put the plus equal all the way over here. We don't want that. We're gonna try and deal with this, but we can't complete the square yet because notice here we have an a. So the way we get rid of the a, we're just gonna factor it out. Okay, so we're gonna factor out that a. So we're gonna be like, okay, a, we don't want you anymore. We're gonna divide you out. So this is what we're gonna have left is just the x squared, which is good. And remember, it's like when we factor out a, we're literally like dividing by a. Remember, we had done that before. We're not dealing with the c just yet, right? So we're just leaving it out there. And some of you guys may be like, you can do that? Yeah, you can totally do that. And then this is just gonna be plus b over a x. And the parentheses, if you include the parentheses, then there's a whole nother thing. But we're not doing, so that's outside the parentheses. So we're only taking out the a of the first two terms. Okay. And then remember what we, so that's this part right here. We just have the x squared plus 8x, right? The negative not minus 9 is over here far away. And then remember we set up the perfect square. So we're going to do that. We're going to set up the perfect square. And we're just going to bring that a down here. And we don't know about the plus c yet. But so what we're going to do now is, remember the way we get the 4 is we just cut this in half, right? So we're going to take the BA. We're just going to cut that in half. So it's going to be plus B over 2A. So see how the 2 is on the bottom, dividing it by 2. All right, so we got that part. Now we're going to square up. Right, that's how we got this part right here. So 4 times 4 is 16. So this is going to be B times B, which is plus B squared. It's hip to B squared. And then here 2A times 2A is 4A squared. All right, so now remember I just added this thing. Now I did add it, except I didn't just add of B squared, I can't say, B squared over 4A squared. I have to multiply that by A on this outside because that's outside of the parentheses, right? So this is actually, so let me just put these in parentheses. So if I were to multiply this back out, this is going to be B squared, I'm gonna put that right over here. So B squared over 4A squared, and then times that by A. So what do we actually get? This is actually equal to A B squared. Oh no, just kidding, don't listen to me. So remember the A's, one of the A's cancel out. So we have one A on top, two A's on the bottom, which means one of those A's cancel out and all we have left is an A on the bottom, right? So this is gonna be B squared over 4A. It's a 4 and that's an A. So that is what I'm gonna subtract out here. So remember I actually added a B squared over 4A instead of 4A squared because of this A out here. So I'm going to subtract that on the same side, right? So we give it and we take it back. So that's going to be B squared over 4A. All right, maybe, sort of, kind of. All right, so now I just need to figure this part out. And I'm like, okay, normally we would just go, oh, -9 minus 16, just add that up. We can't do that here because they're not like terms. So how do I make this have like terms? Well, remember where they have to have a common denominator. So here, so how do we get this to have a common denominator? Well, the common denominator is going to be just 4A. So this is going to be plus 4A. If I can write 4A. So 4A over, well, what's this going to be? This is going to be 4AC, right? Because we just multiplied by 4A minus B squared. All right. And this is literally what that's going to equal to. Just like that. We're going to see this again. But do you see how much shorter that is than what they were doing up here? Which is fine. Okay, it's not that much shorter, but still shorter. See? But that's exactly what, they didn't do like terms. They just left it like that. Maybe we could have left it like that. But see, here's A times X plus B over 2A. Oh, we have 4A. Why do we have 4A? Oh no, we have 2A. Oh, it's right here. Oops. 2A and then the 4A up there. Yep, see? And then, but they just didn't have the common denominator. They just left it at C, which is fine. Okay, but we just did a little better. All right, so now we're gonna go, we talked about it one more time here, and we graphed it. Let's see here. So if we have this equation right here, we know that the y-intercept is at -5, right? Because that's in standard form. That's what it gives us pretty easily. And we just change this to, again, to vertex form to find the vertex. Do you have to convert forms? Can you just find it what the AOS? Yeah, totally. But this is just good practice to change it, to convert to vertex form. Okay, and it's kind of fun, right? And remember, we take out that -5, we just push it to the side here, and we're going to set up the perfect square. And we got this -2 by what? Dividing the -4 by 2, you get -2, and then we're going to square up, so that's going to be +4. And remember, if we add 4, we have to add, not add, well, we could add 4 to the other side, but we don't want to do that. We want to keep it all on the same side. So we're just going to subtract 4, add 4 and subtract 4. We're basically adding nothing. We're not changing the value, just changing the way it looks. Okay, and then so there we go. And then this is -5 minus 4 is going to be -9, right? So literally that's my vertex form. See how it's like 2 steps, okay? They're a little complicated, but it's still 2 steps. And so our vertex here is just going to be 2, -9. Because if you remember, in our this is our vertex form right here, right? If you remember back in season 1, in unit 1, that's what that was. Remember, this was a minus. So this is already a minus. So we're just pulling out that number 2. So that's going to be 2, -9, which means that our AOS is 2. Because remember, the AOS is on the vertex. So if you know the vertex, the X part is the AOS. All right. And then so the way we get our roots is we just factored it. All right. So we just factored this guy and we're like, oh, well, this has got to be 5 into 1 because that multiplies to 5. And one of them's got to be negative. And since it has to add up to -4, we know that negative is going to have to stick with the 5. Right. So that's going to be -5. So we're going straight across. Remember, so don't get confused. We're going literally straight across like this and straight across like this. We're not going that's the biggest mistake here, is that they crisscross the answer, and the answer is not crisscrossed. The method is crisscrossed, but after that we don't crisscross anymore. Okay, we don't just randomly do that. Okie dokie. And then so we got remember we use a zero product property to set them equal to 0. So x minus 5 is equal to 0. Solve for x. And then x is equal to 5. And then again, x plus 1 is equal to 0. And then subtract 1 on both sides to get x by itself. And what is x equal to? Also -1. So here we plotted them 5 and -1. See vertex down here? We have all the points that we need. Okay, excellent. If we wanted to be really, really good about it, and some of you guys may notice I didn't really do that. Oops. Remember this point, this symmetric point here, it's 2 away. It's going to be 2 away over here. So technically it should have gone through that point as well. I would have a much better graph. Do you have to do that? No, you don't have to do that, but just make sure, just to make a nicer graph, right? Be more accurate. All right, and then the only other thing we talked about was the quadratic formula, which is basically kind of like what we already did. We used completing the square, right? And this is on the next lesson. So if you're looking on, see right here, introducing the quadratic formula, we're on page 177. And honestly, I would not even write this down because technically it's already written down for you. What we're going to do here is just, so we completed the square here to solve for something, and we just did the exact same thing using A, B's, and C's, kind of like how we did for vertex form, right? So here, since it's equal to 0 and we're not trying to get it to vertex form, we're just subtracting C on both sides because we can, right? And again, we don't want this A, so instead of factoring it out, we're just going to divide it out. Right? So we just divide everything by A. All right, so far so good. And then we're like, okay, so I know this B over A, I'm gonna just write it B over A and X here like this. And then, so I set up my perfect square and I was like, okay, so I'm gonna just cut this into 2, just like how we did before, right? So that's why my 2 is down here. Square it, so B squared, and then 2A squared is gonna be 4A squared, just like that, because 2 times 2 and then A times A. And then, so once we added this to one side, we got to do that same thing to the other side, right? Which we did. And then we're like, oh, but we need to like kind of put those guys together. Good thing we've already done that before. We're just going to multiply by 1. If I multiply by 1, I'm not changing the value, but I'm changing the way it looks. Putting on makeup. That's how I liken it too. And I don't usually put on a lot of makeup. But here we know that the denominator is 4A squared. This one has an A already. All we need is another 4A. So here we go. So we multiply the top and bottom by 4A, right? Which means literally what's 4A divided by 4A? 1. I'm literally not changing the value. Okay, if I'm multiplying by 1, I could do that all day long, and I'm not going to change the value. Just going to change the way it looks. So what is 4A times -C? Is minus 4AC. Okay, I put this in the back because, because I want it to look like something. And there's no rule against that. And then here's my B squared. Notice it's positive, so it's just going to be this positive B squared minus 4AC. Okay, and then that's again over 4A squared. Okay, so that's what I had. Now you notice the square roots, right? We didn't put that until later, right? Because we're like, oh, well, we need to still solve for x. So we're like, well, let's do it. So let's solve for it. So we got to square root both sides to get rid of the square, right? So that's what the square roots are for. Don't forget the plus or minus. And so now I have, see how this has no more square now? It's gone. So it's going to be x plus b over 2a is equal to plus or minus Well, I have no idea what that simplifies down to, so I'm just going to go square root of b squared minus 4a. And if you look over here, well, what's the square root of 4? And notice we have no pluses or minuses, so we could totally do this. What's the square root of 4? 2. What's the square root of a squared? Well, the square and the square root cancel each other out, so all we have left is the a. Notice that the square root is no longer there because we've already used it. Okay, we're almost there. So now we're going to subtract b over 2a on both sides because we got to get rid of it because we want x equals, right? So here we go, x equals, and then so this is going to be negative b over 2a plus or minus, see the plus or minus? And then I just copied it down, right? Literally just copied it down. And so if you were to find the a, if you were to realize this is the negative b over 2a, where have we seen that before? Remember the AOS formula, right, for standard form is negative b over 2a. Like we've been doing that since like unit 1, right? That's where that is. That's where that came from. I told you we would find out where that came from. That came from here, all right? Plus or minus this guy right here. What is this? Remember from the AOS is always plus this much, minus this much. Like that's how much, that's the distance. That's what that comes from. Okay, so if you don't want to know what the distance is, that's what this is. But most people don't really care about what that distance is. They just want to know what are the roots. That's all they want to know, right? And so this is what we do here. Okay, so we just combine it. So thankfully, these are already like terms, right? 2a and 2a. So we don't have to find like terms. They're already, or common denominators, not like terms. Oh, they're already common denominators. And so it's just going to be negative b plus or minus, put that on top, square root of b squared minus 4ac, right? All over 2a. So remember the song that I sang, Pop Goes the Weasel? You can certainly try it now. Nobody's watching unless they are. Are they watching? And then so remember x equal, I'm not going to sing it, not here. It's forever then. You'll have to come to class then for that. All right, so that's the quadratic formula. And this is how people, come up with formulas, right? They do stuff like this. You're like, well, why would anybody want to do that? Well, we're like, okay, it's either this or completing the square all the time, right? And like if they're like nice completing the square, like where a is positive, we don't have to deal with negatives or decimals or fractions, then that's fine. But what if it's like this, or it was like a 0.5, and here it wasn't bad, but what if it's like instead of a 1, it's like a 2.7, and then what, right? Sad days, right? So then that's why we come into formulas like this. So literally all you need to know is the a, b, and c, and just plug them in. See, now we get to use the c, okay? And that was right here. We only use it once, but it's really important, all right? So this is the quadratic formula, and you can use this to solve any roots, okay, any roots. And if you guys remember on my picture, see, it says, not that I'm putting my mouse around and you can't see that. But see, if you look at the video part where it says love your roots, right? That's literally the quadratic formula. What does a quadratic formula tell you guys? Your roots. So do that. So that's how you remember. Anytime you want to solve for roots, that's what you're going to be using, quadratic formula. Or, right, because the quadratic formula works all the time. Or what I find easier is see if it factors first, because that's the easiest way, and I'm probably not going to get it wrong. Because there's a lot of ways to get this one wrong. If you put it in the calculator wrong, if you like use the wrong square root, it's weird, right? So like a lot of possibilities to get it wrong. So I try and see if I can factor it first. If that doesn't work, then I'll use a quadratic formula. Okay, so that's kind of like my second option. All right, and we'll talk more about the other stuff next time.